Hello. In this video, I would be discussing an introductory explanation of machine learning in the practical application of business analytics to solve real-world problems. My academic background cuts across information technology, accounting, banking, finance, and business administration. I hold a Bachelor of Science honors degree in computer science and information technology from Bowen University. I am an Associate Chartered Accountant, ACA. I am an Associate of the Chartered Institute of Bankers, ACIB, and I am an Associate Chartered Stockbroker, ACS. I also hold a Master of Business Administration, MBA, degree where I specialized in business analytics from the London campus of Hult International Business School. My professional work experience includes 7 years in banking, with the most recent 5 being as a pioneering team member of the Business Data Analytics Unit within the Financial Control and Strategy Department at the group head office of the largest commercial bank in Africa. I have received certified business analytics trainings from globally reputable business analytics consultancy firms, which include McKinsey & Company and PricewaterhouseCoopers. Business analytics is a process of generating business value with advanced statistical models. Business value is typically categorized into profit maximization, cost reduction, and process optimization. This effective application of advanced statistical models is the essence of business analytics, and it is what separates business analytics from business analysis. Advanced statistical models often require deployment in programming software due to their computational complexity. Business analytics requires an understanding of both the underlying business and the technical modeling process. It is my objective to utilize publicly available data to exemplify the practical application of business analytics in the real world. Before we delve into machine learning, it is important to have a holistic understanding of the business analytics process flow. The first step to every business analytics endeavor is the clear definition of what requires improvement. This is known as problem definition. You must then identify underlying key drivers that determine the outcome of the aforementioned and clearly communicate the definition of business success. Business success refers to a quantifiable representation of the desired outcome. The next step is to obtain records related to the critical success drivers traceable to the business problem. The required records, known as data, can be in structured or unstructured forms. Structured data usually takes the form of tables, i.e. rows and columns, and is typically stored in a centralized database either on-premise or in the cloud. An example of structured data is a bank statement. Unstructured data, on the other hand, can be in different forms, including video and audio, and can reside in different decentralized locations such as social media, government reports, etc. After collecting your data, it is important that you ensure the data collected is fit for purpose. You must check that the data is actually relevant to the business case, that it is sufficient to establish key business relationships with your anticipated outcome, and that it is accurate, as inaccurate data will be unable to produce accurate insights. This is known as data processing. It is also important to eliminate outliers that have the potential to skew the output of your model or cause prediction bias. Finally, the pre-processed dataset must be split into train and test datasets. This would be exemplified in our business case. Model deployment is the engine of business analytics. It involves the leverage of high computing power of data science programming software to establish relevant statistical relationships that would have been difficult to determine otherwise. This can be done by coding with traditional programming software or other products such as the Azure Machine Learning Studio and RapidMiner, where minimum use of code is required. After successfully deploying your model, you need to generate business insights. Business insights refer to the interpretation of statistical relationships identified by your model in the context of the business case. This requires a strong knowledge of the underlying business. It would be counterproductive to utilize valuable labor hours to manually retrain models previously deployed. The bulk of your time as a business analytics expert should be spent on innovation and not redundant tasks. Business analytics projects should be done the right way once and then automated. Please note, it is not mandatory that a single person assumes responsibility for the entire business analytics process pipeline, as cross-functional teams that collaborate in an agile manner can successfully execute business analytics projects. Finally, it is important to understand that a business analytics project can only be deemed successful if it creates business value. Business value is typically categorized into profit maximization, cost reduction, and process optimization. Now that we understand the broader business analytics process, we'll concentrate on model deployment and more specifically, machine learning. Machine learning involves exposing your data to an advanced statistical model to identify patterns that can be used to make predictions. Sometimes you have specific business relationships you're looking for. When this is the case, it is said to be supervised. Otherwise, it is said to be unsupervised. Before we go into our business case, I would briefly discuss an explanatory simplified example to help us understand how machine learning works. In a fourth grade class of 100 students, 60 are boys and 40 are girls. 70% of the boys and 52% of the total class are taller than 5 feet. 80% of boys and 10% of girls have short hair while others have long hair. All pupils are aged between 9 and 10. The school serves pupils a snack each day. A different snack is served in each grade. Pineapple popsicles are served in the fourth grade. Only 44% of students like popsicles in the fourth grade. Popsicles cannot be stored, returned nor resold and must be disposed if not consumed. The school orders snacks annually in bulk to earn a 5% discount. 30% of girls in the class like popsicles. 75% of everyone taller than 5 feet likes popsicles. 9 of them are girls. The academic year has just concluded. Assume correlation equals causation. Please pay attention to the differences in the following problem statements. For supervised learning, the school accountant has requested your help to utilize simple statistical measures to estimate next year's pineapple popsicle budget with the demographic data of the incoming class, current third grade. The current 50-person third grade class is 60% female. 50% of the class are taller than 5 feet and 10 of them are boys. All students are 9 years old and 40% of the class have short hair. For unsupervised learning, due to your report to the accountant, ABC Limited, manufacturers of the pineapple popsicles have requested your help to boost their marketing effectiveness by employing simple statistical techniques on current fourth graders' data to advise on driving product appeal among incoming pupils. Note that in the problem statement for supervised learning, we are looking for the estimate of popsicle interest, which is specific, while in the problem statement for unsupervised learning, we don't know exactly what we're looking for. We can statistically represent the scenario with a Venn diagram to drive a pictorial understanding of the use case, where the number of pupils taller than 5 feet, being 52% of the total class size of 100, contains 70% of the 60 boys in the class being 42, we can deduce that only 10 girls are taller than 5 feet in the class. We also know that 48 boys being 80% of boys and 4 girls being 10% of girls have short hair. Further analysis reveals 44 pupils interested in popsicles, being 44% of the class, comprise 12 girls, being 30% of all girls, and 32 boys being 53% of all boys. 9 of the 12 girls that like popsicles are taller than 5 feet, representing 90% of the total population of girls taller than 5 feet, and 30 of the 32 boys that like popsicles are taller than 5 feet, representing 71.4% of all boys taller than 5 feet. The interest in popsicles in the current class can be mathematically represented as a function of height and gender as shown in the following equation. 30 over 42 times number of boys taller than 5 feet times population weight plus 9 over 10 times number of girls taller than 5 feet times population weight plus 5 over 48 times number of pupils shorter than 5 feet times population weight. We know that the number of boys taller than 5 feet in the incoming class is 10, and to obtain the population weight, we divide the population size by the total class size of 50, hence 0.2. Given that 50% of the 50-person class are taller than 5 feet and 10 of them are boys, we know that there are 15 girls taller than 5 feet in the class and the population weight is 0.3. The pupils shorter than 5 feet, on the other hand, constitute 50% of the class, so we know the population size is 25 and the population weight is 0.5. By inputting the data of the incoming class in the statistical function that describes the relationship between pupils' interest in pineapple popsicles and variables such as gender and height, we can predict that only 14.6% of the total class size will be interested in pineapple popsicles. Please observe that age was not considered, as it is almost identical for all pupils and will offer no differentiating business insights. Length of hair was also ignored because there is insufficient information on the actual interest by hair length. This is to exemplify what is obtainable in practice, as some variables will not be suitable for use in your analysis. Guaranteed interest in pineapple popsicles? The demand is predicted to decline from 44% in the current fourth grade to less than 15% in the incoming class. The accountant is advised to limit his order to 8 popsicles daily for the next academic year. Projected decline in interest might be due to change in taste preference, i.e. consumer behavior, rise in competition, or perceived decline in the satisfaction enjoyed from the product, i.e. marginal benefit. In responding to ABC Limited's unsupervised problem statement, the statistical analysis indicates 2 critical factors drive the snack's appeal among pupils. The first factor is the product shape. The class data shows that taller pupils are more interested in popsicles. This could be due to the relatability of the lengthy design of the snack, as 75% of all pupils taller than 5 feet like it. My recommendation to ABC Limited is to create a modified version of the snack to appeal to shorter pupils. The company is advised to explore stout designs. The second factor is the product color. Pineapple popsicles are bright in appearance and yellow in color. This might explain its greater appeal among taller girls, as 90% of girls taller than 5 feet like popsicles compared to 71.4% of taller boys. I advise ABC Limited to introduce darker-themed popsicles such as blueberry, raspberry, or blackberry popsicles to better appeal to boys. In summary, we analyzed the statistical relationship between features of the current fourth graders and their interest in popsicles and utilized the insights to make predictions about incoming students. This is the essence of machine learning. Now, let's discuss an e-commerce business case to exemplify the practical application of business analytics in the real world. Your client, an e-commerce startup, has reached out to your business analytics consultancy firm to identify revenue growth opportunities and build competitive advantage to grow market share. They have provided some data on transacting customers and anticipate your insight-driven recommendations. The data set provided contains the following transactional and demographic information for each of their 350 customers. Please note that the link to the dataset would also be in the description of this video. The strategic objectives for this business analytics venture will be broadly classified into 2. The first is to drive revenue through customer loyalty by reducing the time between repeat purchases for existing customers. And secondly, to improve marketing spend efficiency by reducing the average marketing cost per high-value conversion. Now it's time to launch our studio. I attempted to record the code scripting process, but it was too lengthy. As such, I would be explaining the codes I scripted for this project instead. In the RStudio environment, we start by setting our working directory. This refers to the location of the files we require to run our code. Please recall that to run a line of code in R, you simply press Ctrl and Enter. Next, we install the packages we would need and call them to library. We can now import the dataset to the R environment with the use of read.csv. Next, we view the first 5 rows of our dataset with the head function to confirm the import. Then verify the data types of the variables in the dataset with the use of the str function. The str function reveals that some integer variables such as average rating and total spend are classified as characters, while some categorical variables such as gender, city, and membership type are wrongfully classified as characters. Hence, we need to modify these data types before we proceed, as these variables will not be computationally useful in their current form. After modifying the data types, we need to utilize the str function to verify the change, and then we can view a statistical summary of the dataset. To maximize the business insights from the demographic variable of customer gender, we need to create a dummy variable that represents the gender information numerically. We would use the gsub function to replace female with 0 and male with 1 to make the variable binary and prime for computation. Then we need to use the as.integer function to convert the new binary dummy gender variable data type to integer, and then view the statistical summary of the newly created column with the summary function. Revenue attributable to a customer can be defined as a product of the customer's purchase frequency and their average spend. This implies that an increase in purchase frequency will result in a revenue increase if average spend remains constant. We would be attempting to drive revenue growth by increasing the purchase frequency, especially of our most profitable transacting customers. To commence, we need to create another variable called average spend that represents the average amount a customer spends per purchase transaction. This is obtained by dividing the total amount they have spent by the number of items they have purchased. We can then view the statistical summary of the average spend variable to confirm the absence of errors. The next step is to visualize the integer variables with the use of box plots to detect potential outliers. The visualizations reveal the absence of outliers as all data points are located within a healthy range. Since our strategic objective is to drive revenue through customer loyalty evidenced by high purchase frequency, we need to categorize customers into high and low purchase frequency bands. We would utilize the median of the number of days since the customer's last transaction as the reference data point for classification. Please note that all customers are returning customers as evidenced by the number of items purchased, hence eliminating the risk that a customer's last transaction date is only recent because they are a new customer. We would then create a new purchase frequency variable to classify customers into high and low purchase frequency bands. We have defined high purchase frequency customers as customers whose last purchase date was less than 23 days ago, and low purchase frequency customers as customers whose last purchase date was 23 days or more. We would represent customers with high purchase frequency with 1 and customers with low purchase frequency with 0 to maintain a binary value for our variable. Finally, we view the statistical summary of the new column. Before we proceed to deploy our model, it is important to check for correlation between integer variables. Variables with high correlation should not be used in your model as they have the tendency to create bias in your computation. We would use the core plot function to verify the correlation between a customer's purchase frequency, age, gender, total spend, average ratings, average spend, and the number of items they purchased. Core plot reveals more than 90% correlation between average rating, total spend, and items purchased. They should therefore not be considered for further analysis. Next, we build a secondary core plot without the eliminated variables. This reveals a healthier level of correlation between existing variables that would be suitable for computation. Now we can proceed to build our model. The first step is to divide our data into train and test datasets as explained earlier. We would then train our model with the train dataset and evaluate the output of our model with the test dataset. It is important to set a seed to ensure replication of output during sampling. We would be training our model with a random sample of 80% of our dataset and evaluate its performance with the outstanding 20%. Now we can finally deploy our model. We would be utilizing a logistic regression model to establish the statistical relationship between our independent variables and the output variable. A statistical summary of our model reveals all independent variables are statistically significant at a 95% confidence interval as they have p-values less than 0.05. We can establish the business relationship between the independent variables and purchase frequency by subtracting 1 from the exponential of the logarithm coefficients of each of the independent variables, calculated by our model. This reveals that the probability of high purchase frequency increases by 13.9% for every unit increase in a customer's age. It also reveals that the probability of high purchase frequency increases by 17.8% for every additional dollar a customer spends. This suggests that our client's customer base is likely price inelastic. The statistical business relationship for gender is even more interesting. Recall that we had previously defined females as 0 and males as 1 in the binary dummy variable that represents gender. Hence, a unit increase in gender indicates that the customer is male. The model reveals that the probability of high purchase frequency increases by a remarkable 675% if a customer is male. Now that we have identified key statistical business relationships between the independent variables and the output variable, we would feed the dataset to the model. This is to test the accuracy of its predictive ability and to prove that the statistical relationships identified genuinely represent customer behavior even in an unfamiliar dataset. We use the predict function based on our logistic model on the test dataset. We then create a threshold variable. Logistic regression models compute the probability that the outcome of an event is a category of the output variable. This means that it does not categorically tell you if the outcome is a 1 or 0, but the probability that the outcome is 1. Hence, using a threshold of 0.5 signifies that the model should categorize all predicted observations where the probability of occurrence exceeds 50% or 0.5 as 1. You can therefore modify the threshold based on the sensitivity of the project you are working on. Finally, we create an accuracy table, often called confusion matrix, which compares the predicted outcome of the observations in the test dataset with the actual purchase frequency status of the observed customer. We can see that the true positive rate of the model is 75% as it accurately predicted a high purchase frequency for 24 of the 32 customers tested. The true negative rate stands at 73.7% as the model accurately predicted a low purchase frequency for 28 of the 38 customers studied. Conclusively, we would use ggplot to visualize the relationship between age, gender, and average spend of our dataset to gain a better understanding of our client's business status. From the model, we deduce that there is a 13.9% increase in the probability that a customer will make frequent purchases as they become older by a year. There is also a 17.8% increase in the probability that a customer will make frequent purchases with every additional dollar they spend on average. More significantly, there is a 675% increase in the probability that a customer will make frequent purchases if they are male. We need to apply these insights to the underlying business to maximize purchase frequency based on its ability to drive revenue. The customer demographic with the potential to maximize the three variables observed, with regards to their statistical relationship with customer loyalty and high purchase frequency, are older males with high disposable income. Our client, however, has no customers within the target demographic cluster, as shown by the ggplot2 chart of customer age by gender versus average spend. We would need to find a cost-effective method to reach them and bring them on board as they mathematically have the greatest potential to purchase more frequently. I recommend the creation of a new and exciting feature called Pay for Me, PFM. Pay for Me would allow customers send their shopping carts as links to another party for payment. The process flow to illustrate the Pay for Me feature is as follows. Customer selects the Pay for Me option at checkout. A link is then generated that the customer would send to their relatives or friends to pay on their behalf. When the paying party opens the link, they would be redirected to our client's e-commerce platform, where they would see the shopping cart of the initiating customer. The paying party will then be asked if they would accept to pay or decline. If they decline, a notification of the decision will be sent to the initiating customer, and they would be advised to use alternative payment options or send the Pay for Me link to another party. However, if the paying party accepts to pay, they would be directed to the payment page where they would enter their payment information, which would include demographic details like their gender and date of birth. Information about their location and their relationship with the initiating customer might also be obtained. After entering the required information, the paying party will see targeted ads personalized to them based on their demographic information and be asked if they would be interested in adding some of those items to the cart. The customer can decide to add additional products or proceed with the original cart to complete the transaction. After the transaction, the paying party will be asked if they would like to set up a profile on our client's e-commerce platform with a single click. If the paying party accepts, the payment information entered will be used to open a profile for the paying customer, and we can periodically send them promotional information and targeted ads. We can also incentivize them to make purchases by giving them a discount on their first purchase. It is expected that older males will constitute a large proportion of the recipients of the Pay for Me link, as it is customary for this demographic cluster to be responsible for multiple dependents. The anticipated business impact of this initiative include a cost-effective access to the target customer cluster, the potential to increase purchase frequency of existing customers, because people are likely to buy more if someone else is paying, a cost-effective indirect referral by our existing customers to the target demographic cluster, and the opportunity to maximize marketing effectiveness and efficiency in driving conversions. In summary, we utilized advanced statistical techniques to identify business relationships and patterns that would otherwise not have been obvious to our client, and we utilized the knowledge of the underlying business to make recommendations to the client on strategies to grow revenue, reduce marketing costs, and optimize their customer checkout process. This exemplifies the application of business analytics in the real world.